Hi, Miss Young here, and welcome to video 1 of 3 for lesson 1.3. Lesson 3 is going to be about finding solutions in the different ways that we, different theorems that we have for getting those solutions. In this video, we're going to discuss the factor theorem and the remainder theorem. The factor theorem is if x equals c, so x equals a number, is a solution to a polynomial, then x minus c is a factor of that polynomial. So if we have a solution where x is equal to 2, then that means that x minus 2 has to be a factor of that polynomial. Now, a little bit more complicated in wording, but not in concept, is the remainder theorem. If a polynomial, p of x, so some function, is divided by another polynomial, which is in the factored form of x minus c, then the remainder is p of c, okay? And with that, the polynomial has a solution at x equals c if we were to take that value c, plug it into the polynomial, and we get 0. So what that would look like is if we took x squared and divide x squared minus 4, okay? If we divided that by some polynomial x minus 2, okay, we would then get x plus 2. So this would be the remainder of the polynomial. And a solution at this would be negative 2. And I can check that as if I do negative 2 squared subtracted by 4, I then get 0. So I know that negative 2 is a solution because when I plugged it into the original polynomial, I got 0. We have a lot of equivalent statements for trying to talk about the factor theorem and the remainder theorem. We already said that the polynomial has a root at x equals c, and that x minus c is a factor of the polynomial. We talked about that if we plug in c to the polynomial and got 0, then c was a solution, which talks about bullet points 3 and 4 there. And then intercept being another word for a root or a solution. And then we already talked about if the polynomial is divided by that factor, the remainder is 0. Okay. So here's an example. Determine if x equals 3 is a solution to the polynomial. So we need to determine whether or not 3 works. Okay. They're giving us a solution here, so I would use the remainder theorem and that solution point about if we plug in that number, we should get 0. Okay? We're not asked about what are other factors, is it even a factor, we're just talking about is 3 a solution. So to do that, I'm going to take 3 and I'm going to substitute in for x at all those points. Okay? So I'm going to do 3 to the 5th minus 2, 3 to the 3rd, minus 3 squared, plus 2. 3 to the 5th is going to be 243. 2 times 3 to the 3rd is 54. 3 squared, of course, is 9, and plus 2. When you subtract and add all those numbers together, you end up with 173. Now, this does not equal 0, so therefore, which if you want to write that shorthand, you just do a triangle with 3 dots. Therefore, x equals 3 is not a solution. Okay? We wanted it to equal 0, and here it does not equal 0, so 3 is not a solution. If you were to take this polynomial and divide it by x minus 3, you would, 1, it'd be a very long divisional statement, but 2, you would end up getting 173 as the remainder there as well, and you want the remainder to be 0. All right, For our second example, it would like us to find all solutions to the polynomial if x plus 4 is a factor of this polynomial below. Because we have one factor, in order to find the solutions we want, or all the solutions, we want to find all the factors. So the best way to do this would be to divide our polynomial here by x plus 4. So you're going to need a little bit of room. I prefer to do long division for this, but if you prefer synthetic division, you're welcome to do that. I'm just more comfortable with long division. So I'm going to take x plus 4 and divide it, or take our polynomial and divide it by x plus 4. That would be correct grammar there. 5x squared minus 2x minus 24. All right, so as a reminder, with the long division, we want to figure out what we can multiply to this first term on the outside here to get the first term on the inside. For that, to go from x and get x cubed, okay, we need to then multiply, there it is, multiply x by x squared. So I'm going to put an x squared up here. X squared times x would make that x cubed. Okay. And then I want to, again, since I'm multiplying x plus 4 by whatever's up here, I need to take x squared and multiply that by 4. So plus 4x squared. When we're doing this next step, we want to subtract these two terms. So I'm going to add in a little minus symbol here. So x cubed minus x cubed would be 0. I'm not going to write it. 5x squared minus 4x squared is going to be 1x squared, or just x squared. And I'm going to bring down my other terms. Okay. Now, x times x would get me x squared. So I am going to put a plus x up here. And then multiply this x with the x plus 4. So I have x squared and plus 4x. Again, we want to subtract these terms. So I'm going to put minus and minus. So x squared minus x squared is 0, so we don't need to write it. Negative 2x minus 4x is negative 6x. And I'm going to bring down my negative 24. Okay. To get the negative 6x, I need to do x times negative 6. So I end up with negative 6x. And negative 6 times positive 4 is negative 24. And to subtract these terms, that would make both of these positive. So I'm just going to turn these into plus signs, which would get me 0. So like in the last example, if you were to divide by x minus 3, you would have gotten 173 here. Here we got 0. We already knew that x plus 4 was a factor because it's saying that it is. So that was good. We were trying to make sure that we got this whole polynomial on the top here, okay? This is what is left over that we need to find more factors of to find the other solutions. This is a very easy polynomial 2 factor, okay? If you take x squared plus x minus 6, you're looking for two numbers that multiply to negative 6 that add to 1. Those two numbers are negative 3 and 2. So I have x minus 3 and x plus 2. Okay, so those are my additional 2 factors. I don't want to forget about x plus 4 because we haven't actually we haven't said the solution for that yet. So as you may remember from the Unit 0 lesson on finding a solution, we want to take all 3 of these factors here and set them equal to 0. You're welcome to do that in your head. So our final answer will be x equals 3, negative 2, and negative 4. Those are all the solutions to the polynomial. So like I said, you want to make sure that they told us x plus 4 is a factor. We want to make sure that we don't forget to write that solution as well. Your next steps are to watch the next video for the rational root theorem. I'll see you there.